I guess, no, I need to do this as a separate step. The type levels are separate because I still need the merged vector to make the function call. Existence is pain. Alright, so let's normalize v. And then, what do we want to do with it? I think just return it. Well, wrap it in OK, I guess. Which, is that legal? I don't know if that's allowed. Oh, no, that's not quite true. We don't want to just wrap it in OK. We want to add it to the head of VS. So we want to add it to the head like that. Which fits, nice. And then what we want to do is we want to go vector.fold L. How does this fucking function work? Function value vector. All right. To type OK empty list params. But we don't want to just do that because we'll go two types. This is very dumb. We'll just shorten that. So two types of some vector. And then if that's okay, well, then we need to make a vector from the list and also reverse it. Because here we were adding to the front. Oh, we could do a fold R actually. I'm dumb. We can just fold from the right because this is not a list. It's equally expensive to fold from the left and right. So we don't actually need the list reverse. We can just pipe that into yeah, we can just pipe that into vector from list. That's great. That's good news. I should go and find every place I've done that and stop being so dumb. Okay, I don't know what's going on here. We're skipping that one and that one. Yeah, so just give me a fold Ri, and then we don't need to reverse anything. We go from the right, and then we add things to the front. That's perfect. Ah, beautiful. And then that could be a fold R. Be a fold Ri. We can get rid of this. Okay, let's come back to what we're doing. Okay, so then here we have two types params, two types indices, it feels dumb to have these nested let statements, but I think this is the best way to do it in this case. Seems a bit silly, but whatever. We can be a little bit silly. There's nothing wrong with that. Okay. Now, do we want to do the same thing that we tried to do? I think the answer is yes. Yeah. I think we want to do this. We'll see what the type checker says. Uh-oh. Oh, it's because it's not an okay. T vector can have type A list. Is that so? Fucking what now? Okay. T vector can have T1 vector. Alright. Oh shit, these are different. Because normalize gives us a type T. Yeah, so these are all of type T. Everything in merge is type T, but when we get type... Fuck. Okay. Surely there's an easy way of doing this, right? What is the right way of doing this? If you have a sum type over a bunch of types, right, you're basically just looking for levels. I think everything else is irrelevant. All of these are of type... all of these are of level 0. I think it's only the level 1 that matters. Yeah, a function is a level 0 type. Unless it's a function over... How do I know that? I think I just need to write a get level function. So if you have a type that's like, so if we look at vect, this is a function of what? Level 0. What's nat? It's a schema. What's its type? Oh, good question is, do we use the definition of nat or its type? I think we use this definition, which is prim. So then this will be a primitive. This will be a primitive of level 0. Which I guess technically it's a vector. And then the return type for the function is level 0. Right? I think that's right. So if we have a vector, this is, it takes something in universe 0, then it takes a natural number, and it returns something in universe 0. And the definition of natural is, it's a primitive of type U0, I think. Yeah, it's of type U0. So it's a primitive of U0. So if we swap out the definition of this here, okay, so if we look at the schema, so if we look at vect, this is a schema. Where it's got parameterized type A, which is in U0, and N, which is in N. And it has some shit here that doesn't matter. And so we are joining this together to make a function type A in U0 to N in N2, and then we want to figure out the level here. So we go here, we see the type of A is level 0, or universe 0. The type of this is N, and the definition of N is primitive in type U0. So this is of type U0. So yeah, then we get U0 back. Okay, I think that's the way to do it. These need to be expanded already. I don't know how to do that correctly. Oh, because we've reduced... Yeah, because we've already normalized. Wait, is that right? What does normalize do? Let's get rid of this. I don't think we need that. So normalize, if it encounters an atom, we'll try and get the type of it. Oh, I don't know if that's right. Is it right? Because in this case, it'll give the right result, because the type of n is U0. Is there ever a case where that won't work? I think it's fine. I think it'll work. So we don't want get type here. We want type dot, shit. Oh, they've already been normalized, so it should be fine. Type dot level, I suppose. ty. Yeah, maybe I should get rid of get type entirely. No, that doesn't make sense. I need that.